Thank you all very much for inviting me and for doing all this good work in the first place. And what I'm going to do is talk a bit about some of the ideas that are in my latest book, The Gardener and the Carpenter. And as you'll see, the point of that title is to contrast two different kinds of ways of thinking about how we take care of children. And one way which has become increasingly prevalent over the last 20 or 30 years is this kind of Carpenter model, where the idea for parents or for caregivers is that if we just do the right things, we can shape a child who will come out a particular way. And I think that's not the right model. That's not certainly the model that comes out of science. A better model is to think of the model of a gardener who develops a protected, rich setting in which all sorts of amazing things that we could never have predicted in the first place will happen. And if any of you are Bay Area gardeners, the way that I am, you'll know that we never know how our gardens are going to grow. But we think that in a more profound sense, by creating an ecosystem that has lots of variation, lots of possibilities, lots of diversity, we can have a garden that will adjust to the changing environments and seasons. And I think that's a much better picture of what caregiving is all about than the kind of Carpenter picture that if we just do the right things, we're going to get children who will come out to be a particular way. Now, I'm a scientist. Why am I saying that? A lot of the work that I do comes out of thinking about why it is that we have children at all. I mean, not the sort of obvious reason that we all know, but why is it that we have this long period of immaturity? Why is it that our children depend on us for so long? And it's really striking if you were a biologist from Mars who had come down to Earth 150,000 years ago and you were looking at these newly evolved humans, you'd say, there's something really peculiar about them because they have these completely useless children. So if you look at our closest primate relatives, for example, chimpanzees, this chimpanzee who's a child who's 7 years old is already producing as much food as he's consuming. And even in hunter-gatherer communities, humans aren't doing that until they're 15. And my son is 27, and in some communities like ours, even at 27, we're still paying rent and tuition checks. But that's always been true. So we've always had a much, much longer childhood than any other species has. And that childhood comes with real costs. So we have to put a lot of investment into just trying to keep those children alive. If you look across many different species, what you see is that the longer this period of immaturity goes on, the more parental investment there is, the more different kinds of animals put work and energy into taking care of those babies. And if you look at us in comparison to our closest primate relatives, for example, you can see that we have what I think of as a caregiving triple threat. So we all think about biological mothers as people who are designed to take care of young children. But it turns out that even compared to chimpanzees, for example, we have a lot more people who seem to be designed to take care of children. So for example, we have pair bonding. We have fathers who are involved in taking care of babies the same way that mothers are. And we've had that for as long as we've evolved. That makes us very different from our closest primate relatives. So again, even in hunter-gatherer cultures, men and women are closely attached to one another and they're involved in caregiving. Again, we sort of take that for granted, but it's a really distinctive feature of us as human beings. We also have what anthropologists call alloparents. And alloparents just means people who aren't biologically related to a child who are involved in caring for that child. And again, as long as we've been around, we've had more people than just the biological parents involved and committed to caring for children. A wonderful recent study looked at a group of hunter-gatherers in Africa, and the anthropologist just counted up how many people breastfed each baby. And it turned out that in the course of a week, a baby would be breastfed by 4 or 5 different women. Mothers, obviously, but also other women in the community who were nursing. And they just sort of took it for granted that someone would breastfeed another mother's baby. And as we'll see in a minute, sometimes those babies were even nursed by grandmothers. Grandmothers are the third and my favorite part of the parental investment triple threat. If you look carefully behind those three beautiful grandchildren, those three beautiful children, you can see there's a grandmother lurking in the background. Those, are, of course, are my beautiful grandchildren. Um, it turns out that grandmothers are a very distinctive human adaptation. So again, if you think about it from an evolutionary perspective, it's kind of odd that women are living for so long past the time that they're fertile. And it turns out that this is not true about any other animal species that we know of, except possibly killer whales. And there's an interesting story about killer whales. And it's certainly not true of our closest primate relatives. And again, even if you look in like hunter-gatherer cultures, you see that women are living for 20 or 30 years past the time that they're fertile. Again, that seems very kind of mysterious. But that's actually become one of the leading hypotheses about how human evolution took place. The fact that there were those grandmothers, the fact that there were these women who were available to take care of those needy children for that long period of immaturity was what let the children learn and think as much as they did. Well, that brings us to the next question. Given this triple threat of investment, the grandmothers, the caregivers, the parents, the fathers, why would this happen? What function are those useless babies serving that makes it worthwhile for us to invest so much time and energy into just keeping them alive? And to answer that question, again, we can look across many, many different species. And what you discover is that across a very wide range of different kinds of animals, including not just primates or mammals, but birds, we see this very striking relationship between how long a period of childhood an animal has, how large a brain they have, and how smart they are. So the kind of poster animals for this are actually not even primates, but birds. People have noticed a contrast between two really different kinds of ways of developing. So on the one hand, on one side, for instance, you can see the New Caledonian crow. This is a particular kind of crow that lives on an island off of New Zealand. And crows, ravens, corvids in general, are incredibly intelligent birds. The most recent studies show that they're as intelligent as chimpanzees in lots of ways. And this is actually a bird that's learned how to use a tool to try and get food, something that very few animals are capable of doing. On the other hand, there's our friend, the domestic chicken. And with apologies to any chicken lovers in the audience, this is an apology I always have to make if I'm giving a talk at Berkeley. Chickens are basically as dumb as stumps. So chickens are very, very good at pecking for grain, and they're very good at pecking for grain from the time they're born. They're not much good at learning how to do anything new. Now, it turns out that those crow babies are fledglings taken care of by the adults for as long as a year, and the New Caledonian crows are fledglings for 2 years. In contrast, the chickens are mature within a couple of weeks. And that turns out not just to be true about crows and chickens, but it's essentially true about all the animals in the animal kingdom. So it seems as if there's two really different evolutionary strategies that animals have. One of them is to be like the chicken, perfectly adapted for just one particular environment, very, very good at dealing with that one environment, not very good at changing or learning about new environments. The other option is, which is the one that the crows have, and of course that we humans have, is to be very, very good at learning, very flexible, very good at learning about new environments, not very well adapted to any particular environment. Now, why would that second strategy go with having a long childhood? Well, if you think about it, if the strategy is to learn, you need to have time to learn. And in fact, if you look at what those baby crows are doing in that 2 years that they're fledglings, that can give us a good hint at what function this period of childhood is serving. Because basically what those crows are doing is they're screwing up for 2 years. So what happens is in the wild, these crows can do this amazing thing. They'll take what's called a pandanus palm leaf. So this is a kind of palm leaf. They'll strip off all the leaves and they'll nibble the end and they'll turn it into this barbed digging tool, and then they stick it into a hole full of termites and move it around so the termites stick to the little barbs of the leaves, and then they pull it out and they have basically a termite shish kebab. It's an amazing thing to be able to do. Now, the interesting thing is that in the 2 years that the crows are fledglings, they're basically failing. As we say in the valley, they're failing, and they're failing fast. They put the stems in on the upside down instead of right side up. They put the thick end in instead of the thin end in. But as we also all know from the valley, failing fast is the way to actually succeed. So trying things, having variability, being able to try something new and see whether it works or not, that's the secret to learning. That's the secret to being able to adapt to a new environment. Now, there's just one problem with that, which is that while you're doing that, you're going to be helpless. So while you're in that R&D phase, while you're trying to figure out what the best strategy is, you're not going to be very profitable. And the secret that evolution seems to have designed to deal with this is to give those exploratory learning animals a protected period when those parents and alloparents and grandmothers and mothers and fathers and the village at large can help to take care of those helpless babies. So the reason why we have children, the reason why we have this long period of helplessness, and the reason why, from an evolutionary point of view, it's worth putting that enormous investment into taking care of those children is because that is what enables us to learn. That's the period that lets us learn as much as we do. And that's the period that lets us as human beings, that has let us as human beings spread across the planet and adjust ourselves to all these different circumstances. Now, as I said, doing that depends on having this big parental investment. This picture is a picture of now not birds, but 2 marsupials. Marsupials are the kinds of mammals that, like kangaroos, that have pouches for their babies. And if you look among marsupials, you see, again, this relationship between brain size and parental investment and immaturity. So on one side is the world's cutest animal with the world's cutest name, the quokka. And as you can see, the quokkas only have 1 baby at a time. The baby spends as long as a year in the pouch, and both mothers and fathers are involved in taking care of the baby. If you compare that to, on the other side, the Virginia opossum, the opossum's about the same size as the quokka, but only the mothers are involved in caring for the babies, and the quokka, the possums will have 6 or 7 babies at once. And the babies are mature very quickly, within a month or so. Now, I think if you're a human mother, you may very well feel more like the possum than like the quokka a lot of the time. We could all use more backlighting in our lives. But the crucial thing from an evolutionary perspective is that the quokka brains are twice as big as the possum brains. So what seems to happen, again, is even in this very different kind of set of animals, that long period of immaturity is what enables the big brain and the learning strategies that are so distinctive. And that comes with a big, broad investment in those very young children. All right. Now, if that picture that I've been talking about is right, you might expect to see it reflected in brains and brain development. And probably some of you who have already seen this slide or some version of it. That's exactly what you see. So what you see is that in the early period, there's this tremendous growth of synapses, growth of brain connections. And then what happens is across the brain, the synapses that get used and get strengthened a lot get preserved. The synapses that aren't used get pruned. And the interesting thing is that there really seems to be a big difference in this very quality of brains up until about age 5 and from 5 and older. And one way of thinking about that is that that early brain is really designed to explore possibilities. It's extremely plastic, as neuroscientists say. It's extremely sensitive to information from the environment. It's not very good at doing anything in particular. It's not very good at acting. It's not very good at planning, but it's very, very good at learning. And then there's a kind of trade-off where the brain that we end up with as adults is very efficient. It's very effective. It's very good at doing things. Not so good at being flexible and plastic and changing and learning new things in the light of experience. So the idea is that you can kind of contrast, the way I put it sometimes is you can think about babies and young children as being like the R&D division of the human species. They're the ones who are designed to just be able to be protected and brainstorm. And we're production and marketing. So we take those things that we discovered when we were children and put them to use to do all the things that we need to do as adults. So children and adults in this view, and even preschoolers and school-age children, are really different kinds of organisms designed to do different things in different ways. What the preschoolers are all about is this kind of broad, exploratory learning, this kind of learning that involves understanding possibilities. To get back to this point about investment, this is one of my favorite recent facts coming out of neuroscience. This comes from a paper in PNAS. Get back to that point about how expensive those children are. This is a marvelous study that looked at how many calories are being used up by our brains. And as you may know, as you're just sitting here now, brains are expensive computing gadgets, and about 20% of your calories are just going to your brains. It always feels to me like if you're thinking profound thoughts like a good scientist, you should use up more, but it turns out that's not actually true. So what they did was look at how many calories children are using at various ages. And it turns out that when children are 4 years old, 66% of their calories are going to their brains. So my vision, my 4-year-old grandson who you saw in that picture, is really like this kind of creature out of Doctor Who. He's basically this enormous hungry brain attached to this tiny little body that's turning us all into his slaves, just devoted to keeping that brain fed more and more. So if this picture that I've been describing is right, we might expect that these children would be equipped with very powerful methods for actually learning about the world. And that's exactly what we've discovered. So here's where my specific research goes on. We've been collaborating with people who are doing things like machine learning and AI, trying to figure out what kind of computations are those children's brains doing that allow them to be the best learners that we know of in the universe, to be able to learn things that no computer that we know of, at least now, can learn. One way that children seem to learn, and I talk about this at great length in the book, but I'll just give you one example, is by looking at what other people around them are doing. Just observing, just watching what other people do. And we all kind of know that children imitate adults, but the interesting thing that we've discovered is they do this in an incredibly intelligent way, like little scientists trying to analyze statistics. So how could we show this with 3- and 4-year-olds? Here's what we do. We give the children a little squishy toy, and the toy can do different kinds of things. So you can squish it, or you can squeeze it, or you could pull a ring. And sometimes what happens is the toy plays music, and sometimes it doesn't. And then we just ask the kids to make the toy play music. So what we do is show the children different sequences of actions that sometimes produce music and sometimes don't. And what we can do is, just like a scientist would, we can show that different kinds of statistical patterns that suggest that different kinds of actions are necessary to make the machine go. So for example, if you look at that middle pattern, that ABC pattern, what that means is, for instance, I might show you that I squish the toy, I might show you that I shake the toy and then squish it and then pull it and the music plays. And if I turn it upside down and then squish it and then pull it, the music plays. Or if I pull another ring and then squish it and pull it, the music plays. If I show you that pattern of events, then you should be able to figure out that actually really all I have to do is squish it and pull it in order to make the music play. So if you were looking at this intelligently, you could analyze all those statistics. And in fact, we showed that if you were an intelligent computer, that's just what you would do. You'd look at all those statistics and you'd figure out that that was the right answer. But if the pattern was different, if for instance, you saw that A and B and C were followed by the activation of the machine, you might draw a different conclusion. You might decide, oh no, I actually need to do those 3 specific things to make the machine go. So what we did was we showed children exactly the patterns that I just described to you, and here's what this actually looks like. And we showed them 10 examples.
It is. Isn't it crazy? Yeah, I've never played with it before. So you know what's funny about it? It plays music. But I don't know how to make it play music yet. So I thought that what we could do is we could try some things and see if we can figure it out, okay? You want to help me see if we can figure out what makes it go? All right, so that's going to be our game. We'll see what makes my new toy play music. What should I try? All right, well, what if I squish it, and then I squeeze it here, and then I pull this ring. Oh! I play music! Should I try that again? All right, I'll squish it, and then I'll squeeze it here, and then I'll pull this ring. Yay! I think I should try something else. I'll try something else. What if I squish it, and then I shake it, and then I pull this ring? Do you hear anything? No, I don't hear anything either.
Okay, so this is going to happen 8 more times with these different sequences. And if you're like me, you may have not quite remembered what was it exactly that just happened. But the 4-year-olds are very carefully just watching someone else do something, tracking and paying attention to the pattern that they've seen. And then...
Want to try and make it go? Why don't you make it go? Oh, good job!
So what we found,
I guess we figured it out, huh?
What we found over and over again, and by now hundreds of different experiments, is that even the very youngest children aren't just passively absorbing the things that they see people around them do. What they're doing in this unconscious way is doing these very elaborate, smart analyses of what the actions and events around them mean, and figuring out how they're using that information to figure out creatively how the world works, and then using that knowledge that they've gained about how the world works to creatively do something new, do something that they hadn't seen before, that no one had shown them, that no one would necessarily have thought of. Now, here's the really crucial thing about this experiment. So this experiment, as I say, is just one of many showing just how smart these 4-year-olds are. But here's the next thing that we did in the experiment. You'll notice that Daphne, my graduate student, who's now a professor at the University of Toronto, was actually an MIT computer scientist. So she was very good at being clueless, and she did a lot. She was very clueless when she was doing demonstrating that toy. She said, I don't know how this works. Let's just try it. We did exactly the same experiment. But this time, what we did was have Daphne say, this is my toy. I'm going to show you how it works. So in other words, she acted like a teacher demonstrating to the children. When we did that, the 4-year-olds never, and it's a 0 on the graph, never got to the intelligent solution. So when she did that, all the 4-year-olds did was to imitate exactly what it was that she did. So already these very young children are sensitive to the difference between just exploring something, figuring it out themselves, and being told what to do by a teacher. And as they should, in a sense, they're sensitive to the fact that when someone's a teacher, then you should do what they show you. And let me show you another example of the same difference. One way that children are learning is just through their everyday observation of other people. Another way that we know that children are learning is through play. And we just take it for granted that children play. But again, from the perspective of thinking about the children as being like little scientists, and my first book about children's science is called The Scientist in the Crib, you could think about one thing that scientists do is analyze statistics the way the little boy did in that last experiment. But of course, another thing that they do is they do experiments. And except that when young children do experiments, we call it getting into everything. And again, we've sort of intuitively known for a long time that children were learning when they were playing. But it's really only recently that we've been able to demonstrate this scientifically. And let me show you a nice study that was done by my postdoc, Liz Bonowitz, and my ex-graduate student, Laura Schultz, that demonstrated this. Again, they used a toy, and they showed the children a new toy that could do a bunch of different things. It had a squeaker, it had a light, it had a mirror, and it played music. And then what they did was Just
Hey, Scarlett. What about you? My name is Sydney. Hi. The museum gave me this really weird toy. It's so weird. I've never seen this before. Oh, oops. Did you hear that? Did you see that? Weird. I've never seen that before. That is so weird. This is a really cool toy, Scarlett. I want you to play with it and see if you can figure out how it works, okay? Can you let me know when you're done playing? Okay, great.
Okay, forward two on the
so anyone in the school who's had a portal will testify. You give the portal
It's okay.
and
We know how it fits now, right? Put it back together.
And keep playing, okay?
You want to try
Now, again, here's almost experiment.
I'm going to show you my toy. This is my toy. Isn't it cool?
Yeah. And there's the ball in there.
Yeah. Okay, I'm going to show you how my toy works, Isaac. Watch this. Did you hear that?
Yeah.
Can you let me know when you're done? Okay, great. I'll do it right when I'm done with this. Keep playing, Isaac.
Okay, so we could show that video for quite a bit longer, and you would see that having seen her demonstrate that the way my toy works is by making the squeaker go. In that condition, what the children did was just, again, just imitate what she did and squeak the squeaker. So there's a real kind of double-edged sword of pedagogy, especially for these very young children. And I think there's a very strong temptation because we know how important the early years are, and because we've learned so much about how much children are learning and how much their brains are developing, to think that what we should do is put them in circumstances that look as much like school as possible. We're so used to the idea that learning is something that happens in schools and in school settings that it becomes very tempting to think that that's what we should do with our young children. And that comes back to this kind of Carpenter model, that if we just can do the right things, get the right techniques, we can get the children to come out a particular way. And what the science is telling us, in a way, is just the opposite. The thing that makes the children such impressive learners is not the fact that people have some set of techniques that they've given to make the children end up with a particular kind of knowledge. It's that just by their very biological nature, they're designed to explore and learn and extract what's going on in the world around them if they're in a safe, protected setting with lots of caregivers who care about them and are demonstrating the kinds of things that they just do in everyday life. So it's a very different kind of picture that comes out of the science than the picture that is often prevalent in the education world that's very much shaped by the kind of K through 12 model. And I think that intuitively, preschool teachers and caregivers kind of get it about that. If you talk to preschool teachers, they recognize that that's the way that you take care of children. And they always have. I'll just put this on in the background as I answer questions. This is actually an amazing video of the Child Study Center at Berkeley in 1920. And this was a kindergarten. And the idea was that it was a kindergarten was a garden for children. It wasn't a preschool in the 1920s. And even back then, you can see the children doing the kinds of things that we know from the science are the things that will help children to learn. Playing, exploring, literally Berkeley, being in the garden, listening to people talk, singing, and so forth. So the science, in a way, is telling us what we already knew, but I think that preschool teachers and caregivers often find themselves in this kind of pincer movement where, on the one hand, there are the parents who want their kids to go to Stanford or Berkeley, who think that if we have a more pedagogical setting, that will work. On the other hand, we have policymakers who want to actually show that they've got some bang for their buck and have something that they can easily measure. And the kind of contradiction is that from a scientific point of view, the whole point of having a new generation of children is to enable them to do things that nobody's ever done before, enable them to discover things that nobody's ever discovered before, enable them to be plunked into a new environment and figure out in a brand new way what the best thing to do is in that new environment. But the children can only do that if they're in the kind of setting that you can see with these children. By the way, at one point they take out a bunch of saws and hammers and start hammering in nails and sawing wood, which we'd probably have a hard time. Probably even have a hard time having the dogs and the geese allowed in preschools nowadays. Have a hard time getting the goose drinking the water past licensing, but I think this kind of setting is exactly the setting in which the science tells us that children are actually going to learn the most.